So a balloon is rising vertically above a level, straight road at a constant rate of 2 feet per second. So we know that dy dt is equal to 2. And then it says just when the balloon is 30 feet above the ground, a bicycle moving at a rate of 5 feet per second passes under it. So we know that since the bicycle is moving at a rate of 5 feet per second, we know that dx dt is 5. Okay, and so we've got this situation that, let's see, how fast is we need to find the want. How fast is the distance between the bicycle and the balloon increasing 3 seconds later? Okay, so we have ds, is that an s right there? It looks like an s. Yeah, ds dt. So we want ds dt at the precise moment when t is equal to 3. Okay. Well, at the t equal 3 second mark, if we look at the diagram, we've got t equals 0 right here. And if the bicycle rider is moving at a rate of 5 feet per second, and we want the t equals 3 second mark, then at 5 seconds, he's gone, or sorry, at t equals 1 second, he's gone 5 feet. 2 seconds, he's gone another 5 feet, and then the 3 second mark, he's gone a total of 15 feet. So at that 3 second mark, we know that the x has a value of 15. Okay, and then at that 3 second mark, remember at the beginning, when the bicyclist rode right underneath the balloon was 30 feet in the air. Okay, and so 3 seconds later, if the balloon is rising at a rate of 2 feet per second, then at the t equals 0 mark, the balloon is 30 feet in the air. At the t equals 1, the balloon is 32 feet in the air. 2 seconds after that initial starting point, we have the balloon at 34 feet high, and then at the 3 second mark, the balloon is 36 feet high. Okay, so then that would be a y equaling 36. Okay, so then we have all the information we need. We need to relate our variables, and so that's our relate step. And that relate step would be just using the Pythagorean theorem. We have x squared plus y squared equals s squared. Okay, I seem to remember us doing this problem before, but anyway, when we differentiate both sides, let me use a different color. When we differentiate both sides with respect to t, remember want, know, relate, and then differentiate. Differentiate both sides with respect to t, we get 2x dx dt plus 2y dy dt equals 2s ds dt. I'm going to divide every term by 2 so I can cancel those 2's. We're looking to solve for ds dt, and so we can divide both sides by s. I'm just going to pretend that those 2's are not even there. And when we divide both sides by s, we get x dx dt plus y dy dt all over s, and that's equal to ds dt. Okay. Well, the ds dt at the precise moment, when t is equal to 3, is equal to this. We can put the x equals something now, and then we said already that at the t equals 3 second mark, the x had a value of 15. Okay, and then we're going to multiply that by our dx dt, which we were given in the beginning was 5 feet per second, and then we add to that our current value of y at the 3 second mark, and that current value of y is 36. And then the current value of dy dt. So we're just substituting into the equation just above it. The dy dt again was given to us as 2 feet per second. And then we have this s. Okay, well, when we many times in these kinds of problems, we have this situation in which we have to work for one of the values. So the x has a value currently of 15. The y has a value of 36. And so s squared is equal to 15 squared plus 36 squared. And so let me go ahead and take out my calculator for that. Just kidding. If we divide each of these numbers by 3, then we're going to get something divided by 3. 36 divided by 3 is 12. So if we think about this, 15 divided by 3 is 5. So we have a 5, 12, 13. And so therefore, the length of the hypotenuse is 39 at the time when x is 15, y is 36. And so we get a 39 right there. And yeah, I guess we could go ahead and simplify that. I'm going to erase this stuff here. Erase here. Let me get a bigger eraser. Okay, erase that. So we had to work a little bit for that s, the length of the hypotenuse of that right triangle, when the x again was 15, the y was 36. So we get, in the numerator here, we get 75. Let me get the better pen there. We get 75. 5 times 15 is 75, plus 36 times 2 is 72. Divide that by 39, and we get 147 divided by 39, and that's about 3.769. Now we have to make sure we understand our units of measure, and we're asking where so s is a linear distance, so the distance would be the same units as the rate of change of the horizontal and vertical distance. So that would be feet per second. So feet per second, and that is our answer, 3.769. So reading the question again, how fast is the distance between the bicycle and the balloon increasing 3 seconds later? And that would be it.